Hello.
Okay, so tell me, what is configuration? What do you mean by that?
Hello.
Yes,
Sir.
Sir, arrangement of atom is called configuration.
arrangement of atom what? How? Okay. Hmm? Any other?
Sir, arrangement of atoms in a molecule so that it gains the maximum stability.
No. Stability is not coming in the picture here. Because here what we see, organic molecules are having three-dimensional structure. That means they have got their space the position of the atoms and groups are in as to be described in a space, right? Some molecules are linear, some are trigonal, some are square planar, some are tetrahedral, some are octahedral, all this. So here when we talk of the configuration, so same molecular formula with the compound, we get different isomers. When these isomers, what is the difference between the different isomers is that their arrangement of atoms and groups around that, in this case around the chiral center in space. What are the different types of arrangements? So these arrangements has to be specially named, otherwise we cannot recognize them. So for their recognition, we have to give a specific notation or name for them. So that is what is your configuration. If I say configuration is the relative arrangement of atoms and groups in space around a chiral center, in this case a chiral center. All right. Are you getting my picture? Because my picture is not visible to me here.
No, sir.
No, sir.
My picture is not available. Hmm? Okay, I don't know. This may be a different mode of this Zoom. The Zoom is also changing. Anyway, the whole screen is there. Then we come to this one. Two systems. In this case, one is RS configuration. Already you know, yes or no? Huh? R
Yes,
Yes.
sir.
and gas, and another is DL configuration, DL systems. What is R? R stands for, R means rictus. In the rictus, that is in Latin, that is, it means right. And S stands for sinister. S has come from the word sinister, which is sinister means something bad, sinister design, sinister plan. That means this is not a very positive term, sinister, and that is means left. Why left is considered? Is it left bad? Huh? But this is the normal cultural thing that is also there in our society also. When you are asked to give something to others, you always give it using your right hand. Yes or no? Huh? Your parents ask you to don't give anything with your left hand. Because somehow this was considered bad. Anyway, that is nothing to do with this. The S has come from the word sinister, means left, and rictus means right. So that is these two terms. We will be using these two terms, R and S. How do we get it? But one thing you should remember, R and S configuration assigned to a given chiral center has got nothing to do with the dextro or levo rotation of the compound. You should be clear. Do you know this one or you don't know? Huh? Hello? Suppose a molecule is R with R configuration. Is it going to be dextrorotatory? Always? Hello?
Yes, sir.
So if you know that one, you forget your knowledge. You just wipe out your all knowledge that you have learned from any source. I don't know what was your source of learning. R maybe dextro or maybe levo. You cannot definitely say that all R structures are going to be dextro. No, you cannot tell that. Do you get my point? Hello?
Yes,
Yes,
sir.
sir.
Or all S is also not going to be levo. It may be dextro, it may be. So because this dextro and levo has to be ascertained using that polarimeter, the experimental observation. That is an experimental observation. But here R and S, the configuration is given the molecule is given the configuration R or S depending on the arrangement of atoms and groups in space. That is definite. We just see the molecule in 3 dimension and denote it as R or denote it as S. Am I right? But this point you should be. That is why I have written it specially. Important also that R and S nothing to do with your optical rotation. Then comes. Now you know RNS configuration is assigned to each and every chiral center present in the molecule. Suppose there are 3 chiral centers in the molecule, then all 3 will get its own R or S. Not that only one molecule, whole molecule is given R or S. No. Is every chiral center is given this R or S. This one you know it or not? This particular thing?
Yes, sir. We know.
Okay. This is what you know. All right. And for this, we have to take the 3D structure of the molecule. 3 means 3D means 3-dimensional structure of the molecule. 3D structure of the molecule around the chiral center, and that is tetrahedral structure, which is represented by wedge projection. Wedge projection more or less represent the 3D structure. So we'll use wedge projection to give this RNS configuration. Let us come to the next. So let us do it with a simple molecule, lactic acid. Lactic acid has got one chiral center, yes or no? This is the chiral center.
Yes, sir.
Which has got 4 different groups. A chiral center will have 4 different groups attached to it. COH, OH, CH3, and H. So these are 4 different groups. So it will have 2 isomers because it has got. So what is this? Since lactic acid has one chiral center, it will have 2 configurations of optical isomers, which will be enantiomers of each other. That also we know. And if configuration of one enantiomer is R, other one will be S. That is what we know, and vice versa. Okay, this is what is already known. Now, first of all, this is what you know it or not, rule for assigning the configuration, because we have to go fast. These are things which it is just a recapitulation of what you have done in your college. Rules for assigning RNS, you know it or not?
Yes, sir. We know.
Okay, we know. Let me just give some short idea about that one. We have to consider the 3D equivalent, 3D structure that equivalent to wedge projection. So wedge projection is more or less, it represents the 3 dimension, because we know which one is 2 molecules are in the plane, one is above the plane and another is below the plane. So this way we represent the wedge projection. So that is what, so it is more or less that way. So what we have to do, we have to assign the priority number to each of these 4 groups. So this is very important. Each of these 4 groups will get their priority number starting from 1 to 4. 1 will be the highest priority and 4 will be the lowest priority. And using the rule known as Chen-Ingold-Prelog or CIP rule, priority rule. Now, I am not elaborating on this one. You have to read from different sources, books and other things, and there are different rules. Rules start with a simple one, but as the molecule gets complicated, you have to use those complicated rule systems. So I am not discussing those rules here. You have to. It is your responsibility to know all the rules. Coming to now. Next one. Next step, what you have to do? We have to hold the molecule in front of our eyes in such a way that in such a way that the fourth priority group, which is the lowest priority group, lies at the back of your eyes, back of your vision. Then, after doing that, if you find that if other three groups, that means 1, 2, 3, in front of the eyes happens to be in clockwise direction arrangement, it gets a R. If it happens in the anti-clockwise arrangement, then it gets S. So that is where the simple thing. So here we can see this. Suppose we have to give all these four priority group 1, 2, 3. We'll hold the molecule in such a way that this 1, 2, 3 are in your front of your eyes, and this 4 priority group is at the back. Now, if the arrangement of 1, 2, 3 is in clockwise direction, this is clockwise. The clock moves in this direction. So this structure will get R. And if it is arrangement 1, 2, 3 arrangement is anti-clockwise direction, then that one gets S. Now you tell me in the lactic acid here, which is your priority group number 1?
COOH.
OH, sir. OH.
OH, sir, OH.
So you should be, don't hurry. No, it is first you have to consider the atomic number of the element attached to the chiral center. Here it is oxygen, the higher atomic number will get higher priority. So oxygen is higher atomic number than carbon. Here there are 2 carbon. So both are carbon. So here OH. So OH gets 1. Then which out of this CH3 and COH, which one gets next priority? COH gets number 2, because both are carbon. When both are carbon, same atomic number, then you have to go to the next atom to which it is connected. So here next atom is oxygen, but oxygen is double bond and then OH. So anyway, because this rule I am not telling the details. So this one gets number 2, this one will get number 3, and 4 the highest hydrogen atomic number, that is getting number 4. So let us see how we arrange it here. So here, just see. If our molecule, if we write it like this, COH, CH3, OH, H. So OH is number 1, this is number 2, this is number 3, and 4th priority group we have to hold at the back side. So this one gets number 4. So what is the direction of 1, 2, 3? 1, 2, 3 direction is clockwise, right? So clockwise direction, that means it is R. And the other structure, because one structure is R, if it is R, the other structure will be its mirror image structure. This is the mirror image structure. Just see, this is, if this is mirror, CH3 will appear here, OH will appear here, COH will be just in front of COH, and OH will be at the back side. So obviously this should be S. And you see here 1, 2, 3, and anti-clockwise rotation, so it becomes S. Am I right? Now this is,
Yes,
that means this compound is lactic acid. So this is your R lactic acid, and this is your S lactic acid. This is your S lactic acid. But this S lactic acid, you cannot say that it is going to be dextro oligo unless and until you verify it experimentally in laboratory, or somebody has done the work already and you know it, not by seeing here. And basically, actually what happens, R lactic acid is found to be levorotatory and S lactic acid is found to be dextrorotatory. So don't connect them. Never do it unless and until you are sure that this is what is your dextro or levo, you can tell. You cannot tell it unless and until it is sure. So here we are only giving the arrangement of the atoms and groups in space. Are you clear now? Hello?
Yes.
Okay.
Yes,
So, okay. Now I find 33 people have joined. Next you see, now another thing. Now you see, so these are the, you see, now already you know these things. So I am not There is nothing that I'm doing something new. I'm just emphasizing some points which you have to learn. And these are the tricks also. Now, if this is the arrangement, suppose this is the arrangement. Now, if I make any one exchange, suppose I change the position, I bring CH3 here and COH here. So it becomes exchange of two groups, one exchange, right? So if I make one exchange between two groups, if this is R, the other structure will become S. So just see. Exchange of position of two groups. Suppose we have exchanged CH3 with COH here. So CH3 has come here and COH has come here. In that case, what will happen? This was R, so this will become S. Just see, 1, 2, 3. It is anti-clockwise. Sorry, anti-clockwise direction. So it has become S. And this was S, CH3 and COH just exchange, it has become R. Do you know this? Did you know this one earlier?
No, sir.
Okay. These
No,
are
sir.
the things. These are the things you should learn now, and that will be last time because you will not get any more chance of learning. But so if we make one exchange, sorry. Oh, now the picture has come. Are you getting my picture?
No, sir.
Not yet.
No, sir.
But in my computer it has come. Again it has vanished. Anyway, doesn't matter. Picture is not important. So if we make one exchange, it becomes R becomes S becomes R. Now if we make two exchanges, so what it should become? Suppose this structure I make two exchanges, CH3 COH and then again CH3 and OH. We make two exchanges. Then what should become? R should become what? Tell me your logic. Apply logic.
R.
R should remain as R.
R.
And S should remain as S. So this is what is your important thing. So here what is happening? S is becoming R. So this is now exchanging twice. Let us see what happens. Exchanging twice. That means what we have done from this structure. Okay, this is our original structure which we have just written down here. This is the original structure we have just written down here. Now here what we have done, first of all, this CH3 we brought it here, COH has come here. No, what we have done? No, sorry, this is one exchange, or sorry, these two are mirror image structure. Now here what we have done, this one we have exchanged here. So what we have done, first of all, CH3 was brought here, COH here, and then this CH3 and COH is brought here. That means just we have exchanged like this. We got it. You just turn the position of the groups here. CH3 has come here, COH has come here, OH has come here. So it is two exchanges. This position we are getting by two exchanges. So this was R, just see. This is R already. And what is this one? 1, 2, 3. 1, 2, 3 is. So it has remained as R. And S has remained as S. R has remained as R and S has remained as S. So what is our conclusion? The conclusion is if we exchange position of groups one time, the configuration will become opposite of the existing one. And exchanges are made two times, configuration remains same. Are you clear now? And you have to practice this one. You can learn it through practice only. Okay? Hello? Hello?
Yes, sir.
Okay.
Okay,
Yes,
okay.
yes, sir.
So next we go to the next step. Now this is all important. Now how to assign configuration if the fourth priority group is present, not present below the plane of the, below the plane of the molecule in weight structure. That means not below, not behind, behind your view, not below. That here, what is this one? Just see, the fourth priority group is behind, right? Now, if it is, it's not necessary that always my fourth priority group will be always at the backside. It may be here, it may be placed here, it may be placed here. In that case, what to do? So there are different situations. Suppose the fourth priority group present above the plane. Suppose it is present above the plane. Then what has to happen? So here in this case, suppose OH is here behind the plane, and then OH is here, COH is here, and H is above the plane. Then what has to, so this structure will be what? Now you give the priority 1, 2, 3. So 1, 2, 3. The rotation is what? Rotation is clockwise. But you cannot give it as, because clockwise rotation of 1, 2, 3 is R. But here you cannot tell it R because the fourth priority group is not below the plane. It is above the plane. That means when you turn the molecule below the plane, this configuration will be different. So here it becomes, if you are getting anti-clockwise, that means actually the actual molecule is clockwise. Or if you are getting clockwise, actual molecule is going to be anti-clockwise. So this is clockwise direction 1, 2, 3, but actual molecule should be anti-clockwise or S, the configuration. That is, so it is S, not R. Am I right? Hello?
Yes,
Sir,
sir.
please repeat it.
Simple thing here. So these are the things that you have to learn. Now, what is our rule says? The fourth priority group should be at the back side. But here in this structure, what it is? It's not necessary that always you will get structure where fourth priority group is at the back. Here, what it is? It is in the front. So if it is in the front, whatever rotation you are getting, 1, 2, 3 rotation is coming clockwise. No, actual molecule should be anti-clockwise. So here you are getting 1, 2, 3, 1, 2, 3. So it is clockwise direction rotation. So actual molecule should be anti-clockwise. That is S. Am I clear?
Yes, sir.
Okay.
Yes, sir.
So also can be obtained by exchanging of groups, putting fourth priority group below the plane. Because one exchange we know already that one exchange means R will become S, S will become R. So this rule also you can make it. Suppose here this structure. Oh no, Acha, this is what okay, this is being shown here. Now this one is when fourth priority group is present in the plane. That means here, either here or here. That simple thing you do what you do. Simple thing, just not to have a confusion. Just make one exchange and bring the fourth priority group behind. So you are making this one. If this structure if you bring it here, OH here. So what it becomes? By making one exchange, what you are getting? 1, 2, 3. So 1, 2, 3 is becoming R. Oh, sorry. 1, 2, 3. 1, 2, 3 is anti-clockwise, no? So this is S. So this should be R. This should be R. Am I right?
Yes, sir.
Okay.
Yes, sir.
This one let us check, because I had done it hurriedly, so that might happen something. Just this one, this is also not in the, not behind. So what you do to get this configuration of this one, what you do, make one exchange with the backside group. So OH you bring here, and so what it is, OH if you bring it here, and hydrogen goes there, so OH is 1, 2, 3. So 1, 2, 3 rotation is R. Rotation is R. If this is R, so this should be S. Yeah, in this case it is correct. But here, anti-clockwise, no? 1, 2, 3, anti-clockwise. Oh yes, this is S, so this should be R. So your molecule on in examination is going to be R. Am I right? You get it?
Sir,
Yeah.
please repeat
Yes,
again,
sir.
sir.
Now here, if your what we say, if fourth priority group is above the plane, you know, whatever rotation you are getting, it is the opposite of that. But if it is in the plane, like either here, fourth priority group is here, these two bonds are in the plane of the fetter, plane of the spring. So to get the actual rotation or actual configuration of this molecule, what you do, bring this to the backside. You are bringing it here, OH is here. But actually what we have taken, that means if you are getting some configuration of this one, whatever configuration, this one will be opposite of that. Because you have made one exchange of this from this one, right? Yes or no? Now this one is
Yes,
what?
sir.
This one is what? 1, 2, 3. 1, 2, 3 rotation is what? Anti-clockwise. So this here it is wrong. This is S. So if this is S, this must be R.
R. Okay, sir.
So we are examining this one. So we have to do it like this. Am I right?
Yes, sir.
So here also it is the same thing. We exchange with this one. So OH comes here, H goes there. So what it is? 1, 2, 3. This is what? Clockwise. That means this is R. If this is R, that means this must be S. Because we made one exchange. Because already we know one exchange means opposite.
Sir,
Yes.
sir, if H is on the in the plane and least priority group is in the plane and it is the top, then can we do
Don't,
two exchange?
you say, two exchange, why should you go for two exchange? Two exchange also you can make it. You can make it equivalent structure. But this one will be simpler. You should adopt a simple method. And now you see, probably in your college and other, you have not tried this way, no?
Yes, sir, we
So,
did not.
so you have to learn. You have to learn and have a practice, and it will be simple, very simple. I'm just telling because now let me stop. Let me disconnect because only 3 minutes left, and then I'll reconnect
Hello,
again.
sir.
Yes.
Hello.
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 Yes.
Sir, if the fourth priority group is in the plane,
Yeah.
and if the first priority group is above the plane or below the plane, then we need to interchange between.
No. You see, you need not just look for the first priority. Always, what is the rule? Fourth priority group should be at the back. That way you have to see. You can exchange with anyone. I have exchanged with COH here. With which one I have exchanged? With OH here. I did not exchange. I can exchange also with. I will not exchange with COH because COH is also in the plane. I may exchange with this one. Same result I'll get. Same result I'll get. I should exchange with a group. Sorry. I'm sorry. I have to look for in this structure which is at the backside. This backside group is there, right? Backside group is OH. So I must exchange with this group. We must exchange with this group. The 4th priority group must be exchanged with the backside group. So here also I have, this was here, this OH group is at the backside. So I'll exchange with the backside group because my purpose is to bring H 4th priority group at the backside, right? So it is, am I right?
Yes, sir.
Okay. Only you have to look for the exchange with
Yes,
the
sir.
backside group and the fourth group. So I am just disconnecting because it is already 1 minute left, and then you join again quickly.